Hello everyone, hope you all are well. This is the last part of haloarenes and haloalkanes. In this part, we will discuss about dihalides. We have already studied that dihalides are of two types, geminal and vicinal. Geminal means if both the halides are present on similar carbon atom, then it is called geminal. It is less stable. And when both are present on adjacent carbon, then it is called vicinal. It is more stable. Now we will discuss its preparation. First, from alkyne. From alkyne, what will happen if we react any alkyne, terminal alkyne with alkyl halide, then what it will form? This negative will attack on this carbon and this bond will move further. And here it gives the negative charge and this negative will attack on this positive hydrogen. So here hydrogen will be attached and here halogen will be attached. After this, it will further break because it's double bond. We will again add this. It will again attack on this same carbon and it moves here and this negative will attack on H and it leads to the formation of geminal dihalide. In the similar way, from alkene, we can form vicinal. How it occurs? If we add Cl. If we add Cl, it will be partial negative positive, it will become partial negative. So if it will become partial positive, this double bond will attack here and it will move outside. First Cl will attach here. If Cl will attach here, then this will get the positive charge. Then this negative Cl will attack on it and it will attach here. In this way, you will get the vicinal dihalides. Now from the carbonyl compounds, this is aldehyde and this is ketone. When it reacts with PCl5, we know that from PCl5 reaction removes this group PuCl3. After the removal of this PuCl3, here one chlorine is attached, here one chlorine is attached. This will become primary and this is terminal halide and this is secondary and this is internal halide. Now from vicinal glycol means OH on the adjacent position. On reaction with PCl5, it will lead to the formation of Cl along with the evolution of PuCl3 and HCl. It will lead to the formation of vicinal dihalide. So this is about the preparation of geminal dihalide and vicinal dihalide. Now we will discuss the chemical reactions of geminal and vicinal dihalide. Now in the chemical properties of geminal and vicinal dihalide, first is reaction with KOH. First we take any dihalide R CH2 CXXH. This is a geminal dihalide. What will happen when it reacts with aqueous KOH? It will undergo substitution reaction. This OH negative will attack on this carbon and this halogen will remove. Then what will happen? R CH2 CXXOH. Similar step will take place. KOH negative, this will attack here and this will move outside. You will get RCH2 CHOH. Now in the next step, we have to remove water. This oxygen lone pair will attack on this hydrogen. It will lead to the formation of water and this bond will move here and it will be removed. Now R CH2 C double bond OH. This will be the product. When it reacts with aqueous KOH, then substitution product will be favored. Now if it reacts with alcoholic KOH, what will happen? R CH2 C. Now we can write it as in open way because we have to do elimination here. We know that when alcoholic QH is used, it will undergo elimination reaction. QH. Here it acts as a base. It will abstract this proton and it will move here and this halogen will be removed. What you will get? RCH, double bond CX and H. Now in the next step, this KOH will again abstract this proton and it will form a bond here and it will be removed. What will form? Triple bond. This will be the terminal alkyne. This will be the product when it undergoes the reaction with alcoholic KOH. Now let's proceed further. The reaction of dihalides with potassium cyanide, that is KCN. What will happen in that case? Here we take this as a halogen. In case of, as we take KCN, similarly KOH, it will attack on this carbon and it will go out. In the similar manner, it will lead to the formation of CN. On hydrolysis, it leads to the formation of COOH, dicarboxylic acid. Here the complete hydrolysis will take place. Complete hydrolysis of this cyano compounds will take place. Now third is when this vicinal dihalide reacts with 2 ammonia molecule at 373 Kelvin temperature, then these 2 halogens will be removed along with H. So minus 2HX, it may form minus 2HX and it may lead to the formation of amine. Here NH2 group, here NH2 group. Basically this NH3 will break like this. This H will go with X and this will be with attached. So these are the certain reactions. Now we will discuss last reaction. CH2. This is the vicinal dihalide. When it reacts with sodium salt, what will happen? This negative will attack here and it will move outside. Similarly attack on here and it will move outside. This is called sodium salt or sodium acetate you can say, because this group is acetate. Now what you will get? CH2, CH2. Instead of halogen, there is the attachment of this acetate group. O, CO, CH3, O, CO, CH3. This is an acetate group. So it will become diacetate. This is all about haloalkanes and haloarenes. For more such videos, kindly like, share and subscribe this channel. Now we will begin with one more new chapter. Thank you and have a nice day.